So the first couple of questions here are just your understanding dilutions and solutions. So I've got for a 3:18 dilution, what is the ratio of ammonia to water? So remember 3:18, the top is the serum, parts serum, and the bottom is total parts. So if I wanted to do just serum to water, it would be 3 to 18 minus 3 would be 15. So you could either have 3 to 15 or you could reduce that to a 1 to 5 ratio. Next, for a 22% volume and volume solution is needed as how many milliliters concentrate per 100 cubic centimeters of solution? So 22% of course means 22 out of 100. Volume and volume means both units must be in volume. Well, this missing unit on top is already in milliliters. They're giving us 100 cubic centimeters. Well, a cc is a cubic centimeter, which is equivalent, 1 cubic centimeter is equivalent to 1 milliliter. So this is just 100 milliliters on bottom. Cross multiply and divide. 22 times 100 divided by 100 is simply 22. So that would be 22 milliliters. I think what a lot of people that crossed that one up, it was milliliters and cubic centimeters or cc's. There was the confusion on that one. Next, a 12% weight to volume. When we're doing a weight in volume, remember the weight is in grams and the volume is in milliliters. And again, I think that's what crossed a lot of people up that had this one wrong, is seeing grams and milliliters, and I think you were thinking milligrams to milliliters. So anyway, 12% is 12 out of 100. Again, this has to be grams and milliliters. We have 100 milliliters. Cross multiply and divide, we get 12 grams. Any questions on those first three so far? Okay. So next we need to make a 1:8 dilution of serum in saline. So 1:8, again the 1 is our serum, 8 is our total solution. What volume of saline is needed? We need to make 160 microliters. That's total volume, so that's going to go with the 8. We cross multiply and divide here. 1 times 160 divided by 8 is 20 microliters. So we have 20 microliters there. That is the serum. We're asked what is the saline needed. So we're going to have to subtract. 160 microliters minus 20 microliters is 140 microliters of saline. Now I didn't take any points off on these for units, but here is one where it would be pretty important to have that units because microliters is not a unit that we see often. So whenever you come up with one of those unusual units, definitely, you should label them all the time in the medical field. But definitely when an unusual unit like that pops up, it's very important to make sure it's labeled. Most people would look at that and see volume and assume it would be milliliters, not microliters. Okay, number 5. 50 milligrams of liquid medications. Ordered dose on hand is 3 milligrams or 30 milligrams and 2 milliliters. How many milliliters would you give? You could use the dosage calculation formula here. I am going to just use dimensional analysis. 50 milligrams is the doctor's orders over 1. I need to get rid of milligrams, and I have a relationship here. 30 milligrams is 2 milliliters. So the milligrams will cancel out. 50 times 2 milliliters is 100 milliliters. 1 times 30 is 30. So 100 milliliters divided by 30 is 3 1/3 or 3.33 milliliters. So number 6, cefazoline is to be given on a dose of 30 milligrams per kilogram per day. Child weighs 42 pounds. What amount would be amount it needs per day? So first thing we need to do is we need to take that 42 pounds. We need to convert it into kilograms. So we divide by 2.2. Gives us 19.09 kilograms. So then we're going to take that 1909 kilograms. We'll put it over 1 and we're going to convert that into milligrams. It says 30 milligrams per 1 kilogram. So the kilograms cancel out. 1909 times 30. 572.72 milligrams. If you had rounded that to 19 and had 570, that would be fine. If you did 19.1 and had 573, that is also fine. Any questions so far? 5 or 6? Oops, pardon me? Okay, number 7. Calculate the IV flow rate for 80 milliliters infused over 30 minutes. Now, the first thing we got to do when we're asked for an IV flow rate is we got to figure out what units we want the answer in. We look here, the units are milliliters per hour. So now we come back to what we're given. We have 80 milliliters over 30 minutes. So we want milliliters per hour. We want milliliters on top. We already have that. That's good. We want hours on bottom. Right now we have minutes. So all we need to do here is get rid of the minutes and convert it to hours. So we're going to put minutes on top so they'll cancel out. Hours on bottom. 1 hour is 60 minutes. So the minutes cancel. 80 milliliters times 60 is 4,800 milliliters. 30 times 1 hour is 30 hours. And now we just divide out. 4,800 divided by 30 is 160 milliliters per hour. So again, calculate the IV flow rate for 30 milliliters infused over 4 hours. So again, we need to look for the units in our answer. We're looking for milliliters per hour. So looking at what we have here, we have 300 milliliters over 4 hours. Well, we already have milliliters over hours here. Milliliters on top, hours on bottom. That's exactly what we want. So all we have to do here is simplify, divide it out. 300 divided by 4 is 75 milliliters per 1 hour. So all that we had to do there was convert that to a unit rate. Remember, a unit rate, you just divide by the denominator. So dividing by 4 on top and bottom. Any questions on those last couple? Okay. Number 9. The order calls for 500 milliliters to be infused over 4 hours. So 500 milliliters over 4 hours. Drop factor is 10 drops per milliliter. What is the flow rate? So again, whenever we're asked for a flow rate, we need to figure out what units we want our result in. This is going to be drops per minute. So right now we have milliliters per hour. We need to change both of those. Usually I go after the time first, so I'm going to get rid of hours. Hours are on bottom, so I'm going to put the hours on top. I'm going to convert to minute. 1 hour is 60 minutes. So we can cross off the hours. They've canceled out. We are now in milliliters per minute. I want drops per minute, so I have to get rid of milliliters. And I have 10 drops per milliliter, so I do have that direct conversion from drops, 10 drops, to 1 milliliter. So now the milliliters cancel out. Now I have drops on top and minutes on bottom, which is what I want. So here, let's go ahead and multiply out. 500 times 1 times 10 drops is 5,000 drops. On bottom, 4 times 60 minutes times 1 is 240 minutes. And now again, we just have to convert that down to a unit rate. So we divide by that denominator of 240. So 5,000 divided by 240 is 20.83. So 20.83 drops per minute. The order calls for 1 liter infused over 5 hours. Drop factor is 20 drops per milliliter. What is the flow rate? So again, this is drops per minute that we want our answer in. So I have to get rid of the hours. Let's do that right away. 1 hour, 60 minutes. So the hours will be gone. We are now in liters per minute. We want it drops per minute, so we have to get rid of liters. But we don't have any conversions up here that link anything to liters. But we do have drops to milliliter. So liters to milliliters is a standard conversion that we know. We know that 1 liter is 1,000 milliliters. So that takes care of the liters for us. Now we're in milliliters per minute. We want drops per minute. But we do have that link between drops and milliliters. So now we can get rid of milliliters on bottom, going to drops on top, 20 drops per 1 milliliter. Milliliters are gone, and now we do have drops per minute, which is what we're looking for. So 1 times 1,000 times 20 drops is 20,000 drops. 5 times 60 minutes times 1 is 300 minutes. So 20,000 drops divided by 300 minutes is 66.67. Drops per minute. On either of these last two, if you'd rounded this to 21, that would be fine, and this to 67, that would be fine as well. If you'd round this to 20.8 or 66.7, that is also fine. I didn't specify whether this was manually infused or going through an electronic infuser, so the round off is really kind of ambiguous there. Any questions on those two? Okay, down to number 11. Flow rate is 30 drops per minute. If the drop factor is 10 drops per milliliter, how long will it take to infuse 900 milliliters? So we're going to start with the 900 milliliters and convert that into a time. Well, we've got a drop factor. The only thing we have the milliliters in is the drop factor. So that's 10 drops per 1 milliliter. So now we're in drops. Well, let's see, we've got the 30 drops per minute. So we have drops on top. We're going to put drops on bottom. Going to minutes, so 30 drops in 1 minute. Cancels out the drops. We're now going to be in minutes. Let's go ahead and figure that out. We're asking for the answer in hours. So actually, let's go ahead and take that step and convert minutes into hours. 1 hour is 60 minutes. So now the minutes will cancel out, and we will be in just hours. So 900 times 10 times 1 times 1 hour is 9,000 hours on top. On bottom, 1 times 30 times 60 is 1,800. So now it's just a matter of converting that into a unit rate. Dividing the 9,000 by 1,800 is 5. So that'll take 5 hours. So that one's a little bit different because we are going backwards, starting with the volume. Actually, not kind of backwards. We're looping around. We're starting with the volume and using those flow rates and drop factors to get to what our time had to be. Normally, we were given the time here and use that to go the other direction. Number 12, physician orders a drug at a dosage rate of 60 milligrams per kilogram every 8 hours for a patient who weighs 190 pounds. How many milligrams should be administered every 8 hours? and then how much during the course of an entire day. So we're going to start out with the 190 pounds, and as always, we need to start by converting that to kilograms. So 190 divided by 2.2 is going to give us 86.36 kilograms. So now we take the 86.36 kilograms, put it over 1. We have to get rid of kilograms, converting into medication of milligrams. We have 60 milligrams per kilogram, so 60 milligrams per 1 kilogram. Cross that out, that's 86.36 times 60 gives us 5,181.6 milligrams. The time frame there is every 8 hours. So that's the first one up here, 5181.6. Now the bottom one is per day. So to do that extra step, we go to the 5,000. Let me change colors here. So we've got 5,181.6 milligrams every 8 hours. Converting it to a day, hours here, day here, 1 day is 24 hours. So the hours cross cancel. We multiply that out and divide by the 8. You should get, well, let's do it. We got the 5181.6 times 24, and then we're going to divide by 8. Get 15,544.8. Now, if you rounded off your weight here to 86, you got 5181 or 5180, and 15,540, that would be fine. I allowed for different round offs. So if you did 86.4 and got 5182 and 15,546, I believe it would be, again, those are acceptable. Any questions on those two? Okay, number 13. Physician orders a single dose of 50 milligram methotrexate for a child who weighs 40 kilograms with a height of 125 centimeters. Recommended pediatric dose is 25 to 75 milligrams per square meter per week. The strength is 25 milligrams per milliliter. So our first step here is to find, this is a body surface area, because this is per square meter. So once we notice that's a body surface area, we have to do a BSA calculation. This is a patient of 125 centimeters is their height, 40 kilograms. Since that's metric, divide by 3,600. So the square root of 125 divided by 40, oops, sorry, not divided by 40. 125 times 40 divided by 3,600. 1.18 meters squared is the body surface area. So I would take that 1.18 square meters over 1. And I'm going to start out with the minimum, the 25. So that's 25 milligrams per 1 square meter. So the square meters will cancel here. And then I have milligrams to milliliters. I have 25 milligrams in 1 milliliter. That's from right here. So the milligrams cancel out. I have 1.18 times 25, and all the 25s here will cancel out. So I've got 1.18 pretty much it, 1.18 milliliters. Nothing else is going to be in that. Actually, they're saying milligrams, so I don't need to do this conversion. He's offering a 50 milligram dose is what he has prescribed. So let's go back a notch here. Let's stop right here. Let's do the 1.18 times 25. So So the dosage would be 29.5 milligrams. We don't need to convert to the milliliters there. So that is the minimum. They want to do now what the 75 would be. So let's do the 75 then. Well, the 29.5 was done off the 25. So our titration is going to be 75 over 25 here. So 29.5 times 75 divided by 25 gives 88.5 milligrams. So the safe range is between 29.5 to 88.5, where 50 milligrams is definitely within that safe range. So yes, this is a safe dose. Okay, number 14. Patient is to receive Oncoven 3 milligrams per square meter once per week. Supply dosage available is 10 milligrams per milliliter. How many milligrams would a patient with a BSA of 0.65 receive? So this is asking for milligrams. So we're taking that body surface area of 0.65 square meters, and it is 3 milligrams per square meter. So the square meters cancel out. 0.65 times 3 milligrams is 1.95 milligrams. 1 times 1 is 1. So the milligrams is 1.95. For the milliliters, now we're going to take that milligrams, 1.95 milligram, put it over 1. And we have 10 milligrams per milliliter. So 10 milligrams, 1 milliliter. Milligrams cancel out. This is 1.95 milliliters over 10, or 0.195 milliliters. Any questions on that one? As a group, we tended to do pretty well getting the first part. For some reason, the second part, converting to milliliters, several people had that incorrect. Okay, on to page 3. Patient is ordered Amoxil 0.25 grams every 8 hours. If the available supply is 100 milligrams per 5 milliliters, how many milliliters should be given per administration? So we have here 0.250 grams is the order. To go to milliliters, though, we need milligrams. So I have to get rid of the grams and go to milligrams first. 1 gram is 1,000 milligrams. So the grams are gone. Then we can use the 100 milligrams to milliliters. So 100 milligrams and 5 milliliters. So the milligrams are gone. So we've got 0.25 times 1,000 times 5 should be 1,250 milliliters. Over 1 times 1 times 100 is 100. So that divides out to be 12.5 milliliters. Number 16, we need to make 400 milliliters of 3% solution. So that's 3 times 400. Could have done 0.03 times 400 as well if you want to do it as rates instead of percents. By diluting 8% solution, how many milliliters of the 8% do we need? So it's 8 times that V2, volume 2. So we're going to do 3 times 400 is 1,200 equals 8 times V2. And we divide by 8. So 1,200 divided by 8 is 150 milliliters. Any questions on those two? Okay, number 17. 80 milliliters of 3.5% solution. So 3.5 times 80 equals. This solution is added to water to make the total volume 190 milliliters. What is that concentration? So C2 times 190. So we have 3.5 times 80, which is 280. And we solve that now, dividing by 190 to get C2 alone. So 280 divided by 190. 1.474, 1.47, we'll round that to. That's percent. So the final solution, the 190 milliliters, will be at 1.47%. Again, if you had did 1.474 or 1.50, I would have accepted those as acceptable round offs. An order is given for Enduron 25 milligrams by mouth daily. Or sorry, QD is 4 days. 4 a day. You have Enduron 0.5 milligram groove tablets. How many tablets will you give? So your order is 2.5 milligrams. Put it over 1. We have 0.5 milligram tablets. That's 0.5 milligrams in 1 tablet. Milligrams go on bottom so that they cancel. 2.5 times 1 tablet is 2.5 tablets. 1 times 0.5 is 0.5. And we divide out the 0.5 to make it a unit rate. 2.5 divided by 0.5 is 5 tablets. 19. Our doctor calls for phenobarbital, 0.05 grams. The elixir, so it's phenobarbital elixir. That just means it is a fluid, is GRSS. That means it's 1/2 grain per milliliter. How many milliliters would you give? Well, we have to go from grams to grains here. 1 gram is 15 grains. You look up that conversion out of the book. So the grams cancel out. We have 0.05 times 15 grains so far. And now we can go grains to milliliters. 1/2 a grain to 1 milliliter. So on top here we have 0.05 times 15, the grains have canceled out, times 1 milliliter, which is 0.75 milliliters. And on bottom we have 1 times 1 times 1/2 is 1/2. 0.75 divided by 1/2 is 1.5 milliliters. So that one was mostly a matter of remembering your unit conversions from our last unit. Next, our order calls for Motrin, 600 milligrams. Drug is supplied in GRV, that is 5 grain tablets. So we first must convert our milligrams to grains. 1 grain is 60 milligrams. And now then we can convert grains to tablets. 5 grains in 1 tablet. Grains cancel out. Since it's such a simple cancellation, I'm going to do this. 60 divided by 60 is 1. 600 divided by 60 is 10. So I have 10 times 1 times tablets is 10 tablets. 1 times 1 times 5 is 5. So 10 tablets divided by 5. So we'll take 2 tablets. Any questions on those two? Number 20 was one of the problems that was missed most often as well. Okay, your patient's orders call for Gaviscon 80 milliliters by mouth QID. Gaviscon is supplied in OZXII, that's 12-ounce bottles. Each dose is how many ounces? Well, here is one where the 12-ounce means nothing because that's just the size of the bottle. We're prescribed 80 milliliters. One fluid ounce or 1 ounce is 30 milliliters. That's just a conversion from our last unit. Milliliters cancel out. 80 times 1 is 80 fluid ounces, or 80 ounces. 1 times 30 is 30. We divide that out. That's going to be 2.67 ounces. (22) Find the final concentration of a saline solution consisting of 40% sodium chloride is diluted using 1/8 dilution. Just take your percent times the dilution. 40% times 1/8 is 5%. Physician orders 80 milligrams of an IM intramuscular injectable solution. Only a vial of the solution with a dosage strength of 100 milligrams per 2 milliliters is available. How many milliliters of the on-hand solution should be administered? So you have 80 milligrams is the order. We have 100 milligrams in 2 milliliters. Milligrams cancel. 80 times 2 milliliters is 160 milliliters. 1 times 100 is 100. 160 divided by 100 is 1.6 milliliters. Any questions on those two? Okay, 24. We're getting really close. Should work out just about right for time here. Mr. Jones receives Inderal, 100 milligrams by mouth for dysrhythmia. You have Inderal 30 milligrams squared tablets. How many tablets we administer? Round to the nearest half tablet. Now, it doesn't say round down to the half tablet. It says round to the nearest. So 100 milligrams is the order. We have 30 milligram tablets. So that multiplies out 100. The milligrams cancel. 100 times 1 tablet is 100 tablets. 1 times 30 is 30. That divides out to be 3.33 tablets, or 3 1/3 tablets. That is closer to 3.5 than it is to 3. So it is 3 1/2 tablets that would be administered. Next, an IV bag containing 1,200 milliliters is to be infused over 4 hours. If the infuser is set to 80 drops per minute, find the drop factor. Well, what I'm going to have to do here is I'm going to have to convert hours to minutes, because the only time we have here is minutes. So 1 hour is 60 minutes. So I'm going to cancel the hours. And what I'm going to do is I'm going to figure this out. This is going to give me a flow rate in milliliters per minute. So I have 1,200 milliliters times 1 is 1,200. 4 times 60 minutes is 240 minutes. If I divide that out, 1,200 divided by 240 should be 5 milliliters per minute. So I've got 5 milliliters per 1 minute. Now I do have the 80 drops per minute there as my setting. So I'm going to convert my 80 drops per minute, 80 drops per 1 minute, and I'm going to use this as my conversion factor. Now I have to get rid of the minutes, so I'm going to put minutes on top. So that's 1 minute from here is 5 milliliters. So the minutes cancel. 80 drops times 1 is 80 drops. 1 times 5 milliliters is 5 milliliters. So 80 divided by 5 is 16 drops per milliliter. That's my drop factor. That was a tough one, but several of you did get that right. I was pretty proud of that one. 26. Doctor orders 3.5 milligrams per square meter per day for a patient weighing 137 pounds, 5 foot 7 inches tall. How much medication should be administered? Round to the 10th of the milligram. So we have to find the body surface area again. 5 foot 7 is 67 inches times 137 pounds. Since these are in pounds and inches, we're going to divide by 3,131. So the square root of 67 times 137 divided by 3131 is 1.71 square meters. And now we take that 1.71 square meters over 1. We're going to convert 3.5 milligrams per 1 square meter. The square meters cancel out. We have 1.71 times 3.5 is 5.98, 5.99 milligrams. If you'd rounded to 6, I would accept that. Okay, last problem. The recommended dosage for medication is 4 micrograms to 6 micrograms per kilometer. Sorry, 4 micrograms to 6 micrograms per kilogram per 8 hours. Label on the vial reads 15 milligrams in 8 milliliters. For a patient weighing 165, what is the range? So I have 165 pounds. We divide by 2.2 to make that kilograms. Gives us 75 kilograms. So we start with the 75 kilograms over 1. I'm going to start with the low end of the range, the 4 micrograms per kilogram. Kilograms will be gone. I'll be in micrograms. But I got milligrams to milliliters. So I need to change my micrograms to milligrams. 1 milligram is 1,000 micrograms. So micrograms are gone. We're now in milligrams. And we need to turn it into milliliters. So we have 15 milligrams to 8 milliliters. So the milligrams cancel. So that 75 times 4 is 300 times 1 times 8 is 2,400 milliliters. Over 1 times 1 times 1,000 times 15 is 15,000. So 2,400 divided by 15,000 is 0.16. Milliliters, that's the minimum dose. To find the maximum dose, do our titration. 0.16 milliliters. We use the 4 micrograms. We're going to convert it to the 6 micrograms. So 16 times 6 divided by 4, or 0.16, I should say, times 6 divided by 4 is 0.24 milliliters. Okay, that is it for the test. Like I said, there is that other one posted out there for you on Blackboard. Make sure you pull that out. It's at the very bottom of the list, alternative test 3. Work on that on your own. You can talk to each other and work together if you want to and turn that back in. And I will grade that and use that along with, you can still do corrections on the original one when you get it back. Like I said, if you check Blackboard and your grade isn't out there, that means I haven't received it yet. So make sure you have that resent to me if it hasn't been. And we will go from there. On Wednesday, we are going to pick back into graphing again. So hopefully we're done with dosage calculations. If we have any issues, we will come back and we can work more with dosage calculations again in a couple of weeks when we're done with graphing. Okay, with that, I'm going to let you guys go for the day. We'll see you on Wednesday.